Hi, welcome to the Beam Stop tutorial. In this session, I'll walk you through how to use both the Calibration and Model Builder tabs to fit diffraction patterns. While these two tabs look quite similar, their primary difference lies in their usage. The Calibration tab fits a diffraction pattern loaded from a.xy file, while the Model Builder tab works with a selected diffraction pattern, or mean diffraction pattern, from your dataset. Let's take an example of fitting a CEO2 calibration curve from an actual experiment. On the left-hand side, you'll see your working directory, which matches the one set earlier in the File Manager tab. You'll also see the model directory, where the calibration results will be saved, and the topaz path. You can adjust all relevant fitting parameters, such as the convolution step size, number of background parameters, and x-axis calculation step size. By default, the start and end 2 theta values are loaded from your dataset's x-axis, but you can manually select the range or adjust the step size if you want to focus on a specific section of the dataset. The primary goal of calibration is to determine the correct instrumental peak shape for the diffraction pattern. To fine-tune parameters, go to the Advanced tab on the left-hand side. Beam Stop uses pseudo-void peaks by default, which combine Gaussian and Lorentzian components. The parameters you can modify include GU, GV, and GW, which control the Gaussian component of the peak shape, LX, which determines the strength of the Lorentzian component, Z, which accounts for the zero-error offset. You can choose to refine these parameters individually or all at once by enabling or disabling them in the Advanced tab. To begin calibration, you'll need to import a corresponding CIF file. For this example, I'll import a CO2 CIF file. On the right-hand side, you can confirm that the CIF file is loaded correctly. By right-clicking on parameters, you can toggle their refinement on or off. In the middle table, you can modify the ranges of refining parameters by right-clicking on a cell, or manually inputting new values. In the Code tab, you can enter equations directly, for example, equals 1/3, and the number will be calculated automatically. Adding a semicolon after the equation lets you use fractions instead of decimals to avoid rounding errors. Once you're ready, click Start Calibration to fit the pattern. During the fitting process, monitor if any parameters hit their minimum or maximum limits and adjust as needed. After a fit is completed, you can choose to discard change to restore the previous parameters or save model to save the calibration result in the model directory. If you don't manually save the model, the previous one will be saved automatically when you start another calibration. The Model Builder tab works similarly to the Calibration tab. However, it fits patterns directly from your dataset. To use it, send a diffraction pattern from the Explorer tab by clicking Send Pattern to Model Builder tab, and the pattern will appear immediately. When building a model, you may need to load multiple CIF files. Make sure that structure names don't contain special characters like brackets or commas. If needed, use the Rename Structure button to rename them and avoid errors. In the Model Builder tab, if you don't need to refine the peak shape, you can easily disable peak shape refinement in the Advanced parameters. It's recommended to fit each phase one by one to ensure the best result. When you are satisfied with the parameter settings, click Start Readfield to begin the analysis. A detailed strategy on how to refine parameters effectively will be covered in the case study video. The Model Builder tab also allows you to add single peaks to the diffraction pattern. Navigate to the Peak tab on the left-hand side, and use Add Row or Mark Position from Figure to mark a new peak. Single peaks have adjustable parameters such as position, area, Lorentzian parameter, and crystallite size. This feature is especially useful for capturing peaks from undefined phases or modeling broad background peaks without affecting the refinement process. Once everything is set, click Start Readfield to start the fitting, just as you did in the Calibration tab. In the next tutorial, I'll show you how to use the model you just built to fit the entire dataset. This will allow you to apply the refined parameters and models to the full dataset for comprehensive analysis.